Hello, today I'm going to really move on from a lot of the formal logic topics to do videos that are going to help students maybe in algebra, geometry, trigonometry, those types of classes more. So this can be a bit of a transition for me. I'm not saying I'm going to give up formal logic completely, but I think I've been there, done that, and I want to do something that's going to be helpful for students. Now, this isn't doing your homework for you, okay? This is just a taste of some things that might help. This is hopefully good for parents, teachers also, or anybody who's interested. We're going to discuss the law of cosines. And the law of cosines would be a more generalized case of the Pythagorean theorem. We've already proven the Pythagorean theorem in another video, so we're going to assume the Pythagorean theorem, which would be the law of cosines for an angle of 90 degrees. But the law of cosines, and let's step that up here, would be, if I look at this entire triangle here, we're proving it first for, ignore this area here, this is a little mistake, okay? We're proving it for the entire triangle here, okay, would be that this length, this side C squared is equal to this entire length A squared plus this entire length B squared minus 2AB times the cosine of this angle, which is opposite from C. Now, that's not just true for, and you'll have to pardon me, I meant to draw this line down to this angle here and make this an acute angle. So what I did is I made this an acute angle triangle, but actually, it would work for any kind of triangle provided that this is acute. Okay, so, and it'll also work for obtuse angle triangles, but we're going to start off proving it for angle theta being acute. So my mistake on that, I'll get the hang of these trigonometry and algebra videos as I move along. Okay, this is one among my first, but we're going to prove the law of cosines using both acute and obtuse angles. Starting off with acute angles, and we're going to assume the Pythagorean theorem. Now, note that if my angle is 90 degrees, my cosine of angle would be 0, and I have the Pythagorean theorem right there. So, why do I start off with c squared is equal to a minus b cosine angle squared plus b sine angle squared? How on earth would I start off with that? Well, let's get into it. Right here, I have now put a dotted line through the triangle to represent the height, and that dotted line would form a perpendicular, would form two right angles with this line A. Okay, it's perpendicular to line segment A. Okay, so I have two right triangles that have been formed out of this. Now notice I have a, I don't know what that color is it blue, green, magenta, turquoise, whatever it is. I have a kind of bluish line here and I have an orange line. Now my orange line would be of length B times the cosine of this angle. Well, and which you can see very clearly from the fact that you have a right triangle here and you have B cosine angle. Now what would this be? This would be A, the entire length A, minus B cosine angle, okay? So that would be this length in blue, okay? And notice that I have a perfect right triangle. Oh, and notice also that the height would be B sine angle. That would follow from the right triangle we have here by the definition of sine and cosine. Okay, but notice also that with the Pythagorean theorem, I can say that c squared is equal to this base squared plus this height squared, okay? Which is exactly what I have here. C squared is equal, oh, pardon me, we'll use this line. C squared is equal to A minus B cosine angle, this whole thing here squared, plus B sine angle squared. Okay, and notice that they're both in parentheses. So C squared is equal to this line squared, monitor keeps falling asleep, is equal to this line squared plus this line squared. And this line here would be A minus B cosine angle. Okay. Now, all I do then is I just FOIL these out, and I have, what do I do when I multiply this by itself? I get A squared minus 2AB cosine angle plus B squared cosine squared, cosine squared angle. Okay, and then I just carry this one down and I have b squared sine squared angle. Okay, now what I'm going to do here is I'm going to drop this down, I'm going to drop this down, and instead of dropping this down, I'm going to factor b squared out of both of them, and I'm going to have b squared times cosine squared angle plus sine squared angle. Okay, now what is cosine squared angle plus sine squared angle? Well, that happens to be 1. Now, if you are enrolled in a good algebra class or geometry class and you want to do a video proving that, and I choose the best one and I go ahead and upload it. Now, if you're under 18 or you're still in middle school, high school, you need to either have your parent in the video just to show consent, or if you're a teacher, you can do it as a class project. That'd be fine. But I'll go ahead and take a look at that if you want to prove that cosine squared angle plus sine squared angle is equal to 1. Well, if I have 1 as my factor, then that's just the same thing as having b squared times 1, which is b squared. So these drop down, and you've affirmed that c squared is equal to a squared minus 2ab cosine angle plus b squared. So I've now proven for all acute angles a squared plus b squared minus 2ab cosine minus 2ab cosine this angle is equal to c squared. Now, again, the Pythagorean theorem would be a specific case, okay? But we've already proven that in another video, so we're gonna move on and prove the more general case of the law of cosines for acute and obtuse angles. Now we have an obtuse angle theta, and we're going to prove the very same law of cosine. C squared is equal to, and it's a better drawn triangle, a squared plus b squared minus 2ab times the cosine of angle theta. Okay, so what do we know? We're going to do the very same thing, having a base and a height, and we're going to have this entire length squared plus this entire height squared is equal to c squared. Now, notice that I have a plus b cosine 180 minus theta squared. Well, what's going on here? Well, I have angle theta, and then I have 180 minus the angle here, okay? And we know that simply because this is a straight line, and we have these two angles must add up to be 180, and that's a straight line, okay? So what's going to be my a plus b cosine 180 minus theta squared? Well, we're going to be a little bit miffed on that until we realize that cosine of 180 minus angle is negative cosine angle. Okay. Now now it's all b. The reason I leave b sine angle alone is because the sine of the angle would be the same for theta and for 180 minus theta. Okay, so I have the exact same formula that I have on the other page. It brings me back to, instead of a plus b cosine 180 minus theta, I have a minus b cosine theta. And sure enough, I go through the exact same process that I did before, foiling it out. Okay, then over here separating, factoring out the b squared, and I just have cosine squared angle plus sine squared angle, which equals 1. So that drops off and just kind of disappears from our consideration. So now we have a squared is equal to, pardon me, c squared is equal to a squared minus 2ab cosine angle plus b squared, and voila, we've proven it. Now, notice that if I had a perfect right angle and I had proven the law of cosine some other way other than using the Pythagorean theorem, and my cosine would be 90 degrees, well, that would be a cosine of 0, and I would have the Pythagorean theorem, knowing the law of cosines. So, again, I hope you enjoyed this video. If you want to prove that the cosine squared of angle plus the sine squared of angle of any angle equals 1, again, have a parent in your video if you're under 18, if you're still in high school, or a teacher if you're with a class project. Thank you.